It's a real pleasure to be here, and I appreciate the invitation to talk about a subject that has certainly attracted a lot of interest and discussion in the pig industry, and that is this whole issue of really broadening our diets, maybe that'll be better, to include a lot of ingredients that we weren't previously familiar with. And it's really not really a new thing for us, for the industry, because it's been done in many other parts of the world. But here's really the bottom line. When I ran some feeds, just a straight corn soy diet back in January, and then I opened it up and relatively conservatively allowed alternative ingredients into the diet. That was worth $15 a pig, $15 a ton rather, or $5 a pig. So that's what we're talking about. We don't run into very many people just feeding corn soy diets, but amazingly we still do on some rare occasions. Here's another number that I think says a lot, and that is that when corn was $2.50 a bushel, the cost of a megacal of energy was only 2.9 cents. When corn goes up to where it is now, it's 7.1 cents. So it's more than doubled in cost, and energy is so very important to us, and yet historically when we formulated corn soy diets, it was the biggest question we had on energy was, do we add none or 2 or 4 or 6% fat to the diet? In fact, we really didn't need to have an energy system. Well, that has surely changed now, and it's changed the rules of the game. This is another example of how it's so very, very important. What I did here, and I show the prices that I used for the various ingredients. In the first column, I formulated the diet but only had a spec for energy. And that gave me a total cost for the diet of $210 a ton. Then I added the specs for the amino acids, and that brought the cost of the diet up to $230 a ton. And then when I added in the vitamins and minerals and trace minerals and macrominerals, brought the total cost of the diet up to $244 a ton. So of that $244 total cost, 86% was driven by meeting the energy spec. Now, I'm not saying that energy represents 86% of the cost of feed, because when I'm meeting the energy spec, I'm also providing some amino acids and minerals and vitamins and so on. But fundamentally, meeting that spec is 86% of the total cost. So if we think in Steve's previous presentation where he said that 70% of the cost of production is now feed, if you take 86% of 70%, over 50% of the cost of producing a pig represents meeting that energy spec. That means we better do a darn good job of meeting that spec effectively and at the lowest possible cost. A couple of just basic fundamental principles, and this may, and I don't mean to be to oversimplify, but pigs have requirements for ingredients, for nutrients, not ingredients, and yet I haven't been to any part of the world where nutritionists, producers, and others have a sense that they need to have certain whatever it is that they're comfortable with in that diet. But the reality is, pigs don't really care as long as it's palatable, and the producer shouldn't care as long as the pig performs according to the target. Because pigs around the world are being fed diets very different than what we feed, and the performance is very, very good. And this first example is some typical diets, or better say example diets, not so much typical diets, example diets from Western Canada, where I would be most familiar previously. And you can see it is not unusual that a finishing pig doesn't have any soy in the diet at all. I worked with a pork producer back in the late 1980s who got rid of all the soybean meal from his diet because it was costing him money. And he's an extremely good producer, kept excellent records, didn't lose anything in terms of performance because he replaced his soybean meal with field peas and canola meal. And the number that he gave me in terms of his improved net income was really mind-boggling. If we take a look at some Australian diets, they have a different selection of ingredients to work with. I have huge respect for nutritionists in Australia because they feed lupins there. And if you know anything about lupins, I don't think they have anything in them other than fiber, and yet they feed them successfully to their pigs down there. And you will notice that a lot of their diets do not contain any soybean meal at all, and you won't see corn on that list at all. If we go to Europe, and these diets were formulated for me specifically for a conference a while back by a nutritionist with Nutraco, one of the world's largest feed companies. And so these are very typical commercial diets that would have been fed in early fall of 2011. And yes, they did have soybean meal in all of their diets, but that is driven strictly by economics. It is not driven by any specific requirement that they have. It is just that it's most economical to do so. So pigs are fed many different things around the world and achieve excellent performance doing so. The next point I'd like to make, and I think it follows up very well with one of Steve's comments, is the objective of pork production is financial and it's not performance. And yet we focus so much of our attention on looking at performance indicators like growth rate, like feed efficiency, or pigs per sow per year, and we forget the absolute fact that the farm that has the best average daily gain is not necessarily the farm that has the highest profit. The farm, as Steve said, that has the best feed conversion does not necessarily have the highest profit. So we need to make decisions really on the basis of financial returns, and so they become the primaries, and the performance indicators become information that we use to get there. They become secondary indicators, a means to an end where the end is really financial. The next one also seems so self-evident, and yet, in my experience, and certainly not just in this country, but in many places in the world, this is a very difficult thing to achieve. And that is that everybody working in a particular system or farm is all working to achieve the common goals. And that means everybody from the owner to the workers to the banker to whoever's handling risk management, the veterinarian, the geneticist, and so on. And how many times do we see a situation where, as a nutritionist, I'm brought in to solve a problem with feed conversion isn't where it's supposed to be? And there's no discussion on what the farm's objectives are. It's implicit that it's to make money, but without really knowing the context of what that farm's objectives are, I can't really function as a nutritionist. Am I, as a pork producer, prepared to give up 5 days in growth rate in order to reduce my feed costs by $3, $4, $5 a head? Am I prepared to give up feed conversion in order to reduce my overall feed cost and improve net income for the overall operation? That's the level where we need to be discussing, and that's what I want to be talking about this afternoon. The next point is how we make decisions. And at least one of the criteria for making decisions is this issue of risk versus reward. When Steve brought up the issue of immunocastration, a big part of that decision will be what are the rewards of immunocastration, and Steve showed those very clearly, and what are the risks associated with implementing immunocastration on a particular farm. When we make a decision to introduce distillers grains 4 or 5 years ago into our diets, what was the risks that we were taking, and what are the rewards that we can benefit from? Well, if decisions are made on the basis of risk versus reward, then we get into the issue of whether those risks and reward are real or perceived. So in this grid, let's talk about a reward for a minute. Let's say the reward is real. That if I make a particular change in a feeding program and I know that that's going to improve feed conversion, That is a real reward, and it is perceived that that will be the reward. So we're making a decision with an expectation on the basis of good knowledge. So a great circumstance to be making a decision. But if we move now over to the next quadrant, what if the risk is real, but we don't know that it's there? We may pass on an opportunity because we don't realize that the reward exists. Or maybe worse, we may go forward with something not realizing that there's a risk involved that we're not aware of. We're making a decision with less than complete information. The one that frustrates me the most is this one, where there is no reward, but there's a perception that there's going to be a reward. Or more frustratingly, there is no risk, but we perceive the risk. And I'll bet there isn't a soul in this room that couldn't give us an example of the risks of putting distiller's grains into a pig diet when that first happened. And distiller's grain still gets blamed for all kinds of things. All kinds of things that have really nothing to do with distiller's grains. So this whole issue of risk and reward, perception and reality, plays a very big role on how successful we can be in developing the most effective feeding program, keeping our feed costs as low as possible, and maximizing our net income. The final quadrant, there's no risk or reward and we don't perceive it. Well, ignorance is bliss. There's no downside to that one, so we don't really worry about that quadrant. But this is the quadrant that I worry the most about. This is the quadrant where I like to be in. That's partly because I'm a professor and I do research. We try to understand what risks and rewards are all about. So now let's talk about the challenges. The challenges of implementing a diverse feeding program, and a diet that contains not just corn and soy, but distiller's grains, wheat midds, bakery byproduct, different kinds of fat sources, other potential byproduct ingredients that will vary depending on what part of the country you're in or what country you're from. They can affect us at all levels, affecting the buyer and the receiver of ingredients. It can affect manufacturing and delivery, the feeding and marketing of pigs. And I put formulation at the bottom. Functionally, it's higher, but I left it to the end for a reason. So if we look at what's affected at ingredient buying and receiving, some of these are self-evident and some of them less so. First question, though, is how much money do I have to invest in order to adopt this ingredient into my feeding program? Because it's not like we go to the shelf and take a look in the book and pick up the energy and amino acid levels of this ingredient, decide that we're going to buy it, find a supplier, dump it in the mill, and use it. Because it just doesn't work that way, or at least hopefully it doesn't work that way. We have to invest time and money before we can make the decision. The next one can be actually quite dangerous if we don't have purchasing specifications that are defined and well-known and accepted across the industry. I was in a different country, and we were looking at their ingredients, and they had an ingredient there. We'd looked at the nutrient spec from their quality control program, and it looked like wheat middlings. But in that country, it was called wheat bran. Well, wheat bran, you would put into the computer, if you went and looked at the book, you would put a very different number and a very different value on it if it was wheat bran using our lingo compared to their lingo. But that can apply in our country, and particularly if we're buying an ingredient that people are not familiar with the pig industry, and they have a view that, well, it's only pig feed. And how many times have you heard that? When we built our research facility at Prairie Swine Center the first time, we were running behind on concrete installation, and so the site manager brought in another concrete contractor to help us get caught up. And after the first week that the guy was there, the site supervisor went and looked at it and says, talked to the guys and says, your work isn't good enough. This is crap. And he says, well, what do you mean? It's only a pig barn. Well, they were only on site for a week. right? But we run into that because there's perceptions that we are not inside. We know our industry is very sophisticated. Outside our industry, there's lots of perceptions that we're not. What additional quality assurance procedures do we need to put in place if we're going to buy this ingredient? And we'll be talking about variability, but we know that byproduct ingredients, almost by definition, are going to be much more variable in the nutrient content than our ingredients that are like a corn or soybean meal. Those ingredients, we've been blessed in this country to be dealing with ingredients that are very uniform. And then we bring in distillers' grains, then we bring in wheat middlings, bakery byproduct, ingredients that can vary hugely. And then we take distillers' grains, and we're buying it for a period of time, and it's got 10 or 10.5% fat. The plant puts in centrifugation, and the fat goes down to 8% or 8.5%, but don't tell anybody. If we don't have quality assurance procedures in place, we're going to miss that until we see the outcome of the performance of our pigs. Are the suppliers dependable, and are they competent? And part of that is how they handle the ingredient to maintain its safety integrity. Because what we're doing is we're using ingredients that ultimately end up in a product that goes into the human food chain. And some of the most notorious contaminations, issues that have occurred both in this country, this continent, and over in Europe, occurred because there was not that competency in the trucking part of the system, where the ingredient was dumped into a truck that had previously been used to haul product that was toxic, and of course it got mixed in with the product that we were using in the feed system, and that caused some serious contamination problems. Well, adopting this ingredient presents some receiving problems in our plant. If it takes longer to unload, that's going to put pressure on our capacity for receiving, as an example. And if the new ingredient is added to the mill, how much will that affect the capacity and inventory of the existing ingredients? Because I've never seen anybody yet add a new ingredient to a feed mill and add a new bin at the same time. Right? So we make the decision to add this new ingredient at the expense of something else. So if we have 3 bins of X and now we want to bring in a new ingredient, we're now down to 2 bins of X plus the bin of Y. Well, that puts pressure on our buyers and receivers because now they only have the buffer of 2 bins to work with where previously they had 3. So it complicates the system. In manufacturing delivery, how will plant throughput be affected? And I'm going to give some specific examples there. And where is it going to be affected is in terms of where's the limiting point in our mill? Is it grinding? Is it mixing? Is it pelleting? Is it load out? Every feed mill has a point of constriction. That point that limits the overall output for the plant. And when we add a new ingredient, we need to understand before we even start what the implications of that are going to be. Will new constraints to production flow result from the use of this ingredient? And will feed quality be affected? What changes in production are required to maintain quality? When Steve was talking about pelleting, we bring in a new ingredient, might improve pelleting, might make pelleting worse. But we need to know that, and we need to make the appropriate adjustments in order to maintain the quality of our product. And particle size and uniformity are critical. We did some research last year that showed that we could change the energy value of corn by, I think it was in the range of 5%, by changing the standard deviation of particle size from 2.33 down to 1.88. That's just changing the variability of particle size. That's not changing the particle size itself. And Steve has showed you what happens when you change particle size. But let's take a look at one of the aspects of mill capacity when we bring in a different ingredient. And this is the bulk density of various ingredients. And We didn't used to be very familiar with tables like this, but we're a lot more familiar with them now. If we take a look at corn, has a bulk density of about 37 pounds per cubic foot. And soybean meal has a bulk density of 41 pounds per cubic foot. So if we're making feed in a 110 cubic foot mixer, then we can pretty easily put in 2 ton. That would be a 2-ton mixer. But if we go to distiller's grains, the bulk density is only 30 pounds per cubic foot. Then all of a sudden, that mixer that would hold over 4,000 pounds of corn will only hold 3,300 pounds of distillers. If we're putting in wheat midds, that mixer that would hold 4,000 pounds of corn will only hold 2,200 pounds of wheat midds. Now, of course, we don't use 100%, but the point is we can change the whole flow of our system because the mixer capacity can change, our storage capacity for loadout can change, the hauling capacity of our truck fleet can change because it's a fixed volume that we're dealing with. And if we go to less dense ingredients, we've had a profound impact on our capacities throughout the whole system. The amount of feed that's going to be in a feeder in the barn could change. And that will dictate how often we need to be checking to make sure the automatic feed delivery system is working. As I mentioned, quality control is going to have to become so much more important, or has become so much more important. And strangely enough, one of the challenges is, what should we be measuring? And then the biggest challenge is, once we have done the measurement, what do we do with the data? If I'm bringing in distiller's grains, for example, and it's coming in at 38%, let me bring in wheat midds at 16%, and all of a sudden that wheat midds is dropping to 15%. I brought in a load. Do I change the spec that I formulate with? Because the next delivery might be back up at 16. Or do I wait then for 2 loads to come in, or 2 measurements that shows it's down, or 3? I don't even have to talk about wheat midds or distillers. I can talk about corn. If you go to any textbook and look to see how much protein there is in corn, it'll say 8.5, 8.8% crude protein. There is not very much corn out there anymore that's got 8.5% crude protein. Right? So quality control becomes so important, but more critically, it's easy to implement a quality control program if you're prepared to spend the money, but what do you do with the information? What kind of critical control points do you put in? What kind of decision-making tools do you put in place to make informed decisions effectively and end up with the quality of product that you want? And I'd like to advance the concept that our traditional quality control program looks like this. It includes, in some way, some evaluation of the ingredients, and in some way, an evaluation of the feed manufacturing processes, and an evaluation of the mixed feeds. But most quality control programs don't include the pig. When Ford Motor Company, I was reading a really interesting article a while back on Ford Motor Company, and when they realized that they had a quality control problem and that their vehicles were never rated highest in terms of quality and consumer repair records and those kinds of things, they realized they had to change it. And gosh, you go back probably more than a decade and you would hear, at Ford, quality is job one. Well, what they did, one of the key things they did was they put more focus on the quality evaluation of the final product, in their case, the cars and trucks. In our quality control programs, we put our evaluation, in terms of feed, on the feed. Steve gave a really nice example, thanks for doing that, Steve, on pellet quality. You measure pellet quality at the pellet mill, and it looked pretty good. But the pellet mill isn't the customer. The customer was the pig in the barn, and when you measured pellet quality at the barn level, got a very, very different answer. So I believe, and I've seen it already, that we're going to see a quality control procedures that really look at the pig, and the carcass and the issues with soft fat in the carcass is helping to drive that. Here's an indication of the variability of distillers' grains. This is from Jerry Sherson, who's done a huge amount of work on distillers' grains. And even with conventional distillers, crude protein of 30% and a range from 29 to 33, that's not, when you convert that to available lysine, that's not a huge variation. But if we look at energy, the average was 1728, but ranged from 1590 to almost 1850. Now that is huge. If we look at the fiber content, range from 5.4 to 10.4, twofold range in fiber. Ash content, a threefold range in ash content. Now those are things that are going to affect the nutritive value of distillers' grains. How do we evaluate it? How variable is it? And what do we do with the information? And just as an aside, when we look at lysine digestibility in distillers' grains are heated as part of the drying process. And it's estimated that we are overestimating the available lysine content of distillers' grains by something in the range of 10 to 20%. Because the method that we use for measuring amino acid availability, ileal cannulation, does not pick up differences due to heat damage. So if the lysine that is bound to sugars due to the heating process, it will be absorbed by the pig. So according to ileal digestibility measures, we will think it's available, but the pig can't use it. And so it's not available. So anything that has been heated, we have to look at amino acid availabilities very carefully. So some of the implications for feeding pigs. I often encounter the perception that when we feed alternative ingredients to pigs, that we actually expect performance to suffer. And our mindset really should be that if we're doing it right, performance shouldn't suffer. Performance might change in a way that we predict it will. We accept, for example, we're going to use lower energy ingredients. We're going to lower the energy level of the diet. We are going to accept a rise in feed conversion. We're going to accept, in some circumstances at least, a change in growth rate. But they should be predictable. Just because we use byproduct ingredients does not necessarily mean that we're going to suffer in terms of animal performance. So when we put together a feeding program, the way we would start it is, first off, we look at nutrient requirements. What pig are we feeding? And how fast is it growing? What is it eating? And therefore, what should we be feeding it? Because all pigs are not created equal, and we can't just look in a book and say, oh, the lysine requirement for a pig at this stage is 0.80%. There's way too much variability from barn to barn, from genetics to genetics, from health status to health status. For example, the lysine requirement of a 150 pound pig that's growing 1.7 pounds a day versus one that's growing 1.9 pounds a day, the difference in lysine requirement is about 0.05%. So why would we feed the same level of lysine to a pig that's growing 1.7 pounds a day as we feed to a pig that's growing 1.9? Now, if we're making money in the pig business, we can say, well, because I'm working with that herd or that barn or that system to get growth rate up to 1.9, and if I've got money, I've got some margin to play with, then that's maybe okay. That's a management decision. But if I'm already losing money and I'm overfeeding pigs relative to what they're performing, I'm increasing my losses. And we know it. And we can predict it. And so we have to define our nutrient requirements based on the pigs that we're feeding and the amount of feed that they're eating. Once we know the requirements, then we can determine where are we going to bring those nutrients from. What ingredients do we have available to us that are economical that we can use in our system? And then we build a feeding program. And I say we build a feeding program because we do not formulate diets anymore. We develop feeding programs because what we feed to a pig at 50 pounds dictates what we're going to feed to it at 100 pounds, which dictates what we're going to feed to it at 150 pounds. Okay? There are some people who are intentionally underfeeding pigs at 100 pounds to capture compensatory gain later on. I think we need more. Risk reward. I'm way too far on the risk side of that right now. But if we get more information out, that might be a way to do it. That might be a way to reduce the cost of feeding our pigs and maintaining the same performance. So there is data out there that says that it can be done. So we develop our feeding program, but that feeding program will have an impact on pork quality, on our net income, and on the sustainability of our system. And note that the arrows all go in the opposite direction. Because the feeding program that we're going to use when there's maybe a margin of $20 a pig available is hopefully going to be different than the feeding program that we're going to follow when we're actually losing money in the business. Right? And so this can affect this and this. Pork quality can certainly affect nutrient supply as well as nutrient requirements. So it's a very integrated system, and we got to consider all of those components in order to come up with a system that's going to work the best for us and give us the most predictable results. The one thing that's not in here, and let's just say that this would be classical nutrition, graduate nutrition 101. This is a growing recognition that while the ingredients that we supply to the pig supply energy and amino acids and so on, they also can have an impact on the gastrointestinal tract. Right? That if we feed higher fiber ingredients, that can have an impact on the gut. That if we feed certain kinds of fiber, we can actually lower the pH of the upper gut, which is favorable relative to certain pathogens, or other diets will raise the pH of the gut and would be favorable to pathogens. So if I was much younger than I am now, just starting out, I think this is a huge opportunity. And certainly there's people doing some really exciting research in that area. But I think it's going to really change how we do things. So when we're talking about formulation, because we've gone from corn, soy, and choice white grease to multiple diets and diet ingredients that are highly variable, the formulation of pig diets has become much more complex. For just as an example, as we change the level of fiber in the diet, that changes the threonine requirement. And since the threonine is often second or third limiting in most practical diets, and since we generally feed threonine at the requirement and not above, that has some very practical implications for what we're doing, and we are feeding more fiber. That ingredient-based formulation really is a thing of the past. This one, all energy in the diet is not the same. Energy comes from different sources in the diet, and they may be used differently by the pig. I want to study lysine. I analyze lysine. It's a chemical entity that I can measure. I can determine its availability. I can determine its quantity in the diet, in the ingredients. I can add them together and say, this is what's in the diet. I can't do that with energy, because that's what energy looks like. Yeah, I can do a bomb. I can do calorimetry. That's the new language we should be using now. We were standing in line at the airport, and a guy was talking about our new bomb calorimeter and said, no, don't talk about new bomb calorimeter in line at the airport. We can measure that, but it oversimplifies the situation, because energy comes from protein, energy comes from fiber, energy comes from other carbohydrates, and energy comes from fat. And how the pig uses that energy differs depending on the source and depending on how the energy is being used. So, for example, if fat is being used for maintenance, then it's used with an efficiency of 65%, maybe. But if that fat in the diet is being used to deposit fat in the carcass, it's being used with 95% efficiency. And conventional formulation programs don't take that into account. When we're talking about protein, well, the only protein that's in the diet that supplies energy is those amino acids that are not used to build muscle and lean. So it's not all the protein that's present. If I do a bomb, that includes all of the protein, but only the protein that is not used for the synthesis of protein is actually available for energy, actually supplying energy. So energy is the most costly component of the diet. We used to take energy for granted because at 2.1 cents per megacal, that's pretty cheap. I remember being in Western Canada where energy was cheap too, and Europeans would come over and visit us and say, "Man, your diets are cheap here." And we'd say, "Yeah." Not really thinking of the consequences of that simple statement, because sooner or later that caught up with us as well. And then we look to the Europeans, so what are they doing? Because they've been dealing with high-cost ingredients a lot longer than we have. So are we using dietary energy most effectively and most efficiently? No, we're not. The correlation between, Steve, you were talking about energy not being a very good driver. And we had an experiment very carefully controlled. We knew exactly, we measured the exact amount of energy in the diet, and we knew exactly how much energy each pig was consuming. The correlation between energy intake and feed efficiency was between 0.1 and 0.15. Because there's so many other variables that affect feed efficiency. Now, turn that around, because you're saying, well, but John, everybody knows that if you increase the energy concentration of the diet, you get better feed conversion. And yes, that's true. So if you want to improve feed efficiency, you can increase energy, and unless something else has gone wrong or preventing it from happening, you're going to get better feed efficiency. May not be cost effective, but you get better feed efficiency. But I guess the word is noise, Steve. There's so much noise in that measurement. And not, in this experiment, we took out all of the weight on test and weight off test and all those other things. These pigs went on test the same weight, came off test the same weight. So we took out all that kind of noise. Mortality was not considered, was not a factor at all. And yet the correlation was still 0.1 to 0.15. So here we can see what is the cost of energy from different ingredients. And again, I show the cost of the ingredients. Corn at $220 a ton, DDGs. But of course, that relationship varies. But the cost of energy on the ME system, 7.1 cents for corn, about 7.2 cents, so about the same from wheat middlings. But if we look at the net energy system, and I don't have time to get into net energy today, but if we were looking at the net energy system, middlings is not nearly as economical ingredient when we're using the net energy system as when we're using the metabolizable energy system. And the NE system does a better job of defining the actual amount of energy available to the pig. So typically we feed pigs to achieve a growth rate, to move pigs out of the barn according to schedule, but I'm wondering at some point, and I think a number of producers have already decided that, but there's certainly some producers that have not. At what point does feed become so expensive or energy become so expensive we just say we are not going to supply the same energy levels to get the same growth rate? We just can't afford to do that. How we feed the pigs and the ingredients we use can affect carcass iodine value. If a packer's looking for an IV of 74, we fed tallow at 3 and 6% of the diet, didn't have any problems. We fed choice white grease with an IV value of 67. You can get choice white grease with an IV value of over 80, by the way. And we still did not have any difficulties with IV. But when we fed corn oil, i.e. distiller's grains, because that's what it supplies, Notice here that we didn't get a dose response. Whether we fed 3 or 6%, we got the same iodine value, but when we fed corn oil, we got a definite dose response. Ingredient maximums and minimums, we put those in when we formulate, and we say we want a minimum of 10% soy in the diet, we want a maximum of 30% distillers grains in the diet. In a perfect world, we should be going to where we don't have those kinds of limits, and we should only have limits based on characteristics of the ingredient that we know we have to deal with, like anti-nutritional factors. We're trying to deal with carcass quality issues like fat. We're trying to deal with manufacturing issues like bulk density. Oftentimes, we're using those limits based on incomplete information. We just finished a trial of a very large integrated operation, feeding distillers grains at 60% compared to 30%. And we're just getting the rough data back, but if there is a difference in performance, it was very, very small. Very, very small. Here's an example of if we do have the information and just for it, it can work. These are 11 different varieties of field peas, all grown on the same quarter section of land, 160 acres. Energy varied by 22%. When we measured the energy and then formulated diets to an equal energy level, we got almost equivalent feed efficiency. Still got a couple that were abnormal, so there's something other than energy that was driving that. But the point being, if we have the information and formulate accordingly, we can be successful. I'm going to skip this and this. In conclusion then, the gross savings accruing from the use of novel ingredients have to be balanced against what we have to invest in order to use those ingredients. The analytical costs associated with developing a matrix initially and then doing quality control on an ongoing basis, logistical costs that go on in the mill or on the farm, any loss in capacity in the milling system, which may accrue as a result of the use of this ingredient, and then farm implementation issues related to flowability, bridging issues, impacts on palatability, and so on. But I believe that with sufficient time and knowledge and research that we can come up with the data, and already have come up with the data on so many ingredients. Because remember, it wasn't that many years ago, soybean meal could not be fed as a sole protein source to pigs. If you fed soybean meal to a pig, you lost performance. That was before we knew about vitamin B12. Okay? So with, I think that really financial success in pork production going forward will really depend on our ability to use as diverse ingredients as possible to get predictable performance, but most critically, get the financial outcomes that we're looking for.